So good evening, Tim. It's time for you to start the presentation of the Linux latest status update.
Okay.
Could you please speak something and prepare the presentation?
Yes, I think I introduced myself. I'm Tim Bird, and I haven't. This is the first time I've talked to Jeff for quite a while. We used to work together way back, very beginning of embedded Linux and Lineo, so it's good to hear a familiar voice. And I'm happy to talk to everyone today. I'm going to share my screen now. So let me see. I'll get my presentation going here. So is my screen now on the projector?
Yes, it is.
Okay. Great. Well, my name is Tim Bird. I'm the Architecture Group Chair of the CE Work Group of the Linux Foundation. This presentation is one that I give quite often. I repeat it because there are things always changing in Linux. I tend to kind of rotate stuff off, so there may be a little bit of overlap with the version of this presentation that I gave in December at the Jamboree. But hopefully there'll be some new material. There was a lot of interesting things that happened at Embedded Linux Conference, and I'll try to give some of the highlights about different kernel versions, things that are going on in terms of technology interesting to people working at Embedded Linux, as well as talk about the CE work group, the current projects that we're pursuing, and just kind of an overview of where I think things are. So this is the high-level overview, and I'll just dive right down into kernel versions to start with. So this is a list of the kernel versions we've had over the past approximately a year. And so version 3.14 is over a year old now. And you'll notice that we seem to be on a pretty consistent cycle, just a little bit over 2 months, or 63 days. The last 3 versions have been done in 63 days. And we're at 60 days so far on the 4.0 version. We're currently at RC7, which is a pretty high RC number. Given what Linus has been saying on the mailing list, I think we'll probably either see the official 4.0 release this weekend or next weekend. But things seem to be settling down. His last message had just a few more fixes coming in. So I think we're in pretty good shape. We already have a really good idea what's in 4.0. It'll be really interesting to see what the 4.1 merge window brings. But we'll, just by way of kind of going over quickly, we'll look at some of the versions we've seen in the last year and kind of what's been going on with them. So version 3.14 was the last long-term stable kernel version. So Greg Koa-Hartman he maintains each version for a little while and then passes it off. He tends to hang on to the long-term stable versions. Those he supports for 2 years. The LTS version, and he collects patches from people that are marked. When people contribute a patch to the kernel, if it's a bug fix that applies to one of these long-term stable versions, he collects those in and has released these. He's up to release 37 on the LTS version as of March of this year, and he has said that he will continue to support this actually a little bit longer than 2 years, up until about August of 2016. And the current LTSI kernel, which I'll talk about later, is actually based on 3.14.28. So that is actually based on top of that LTS kernel. If you look at a couple of little things that came in 3.16, there was power aware scheduling. Well, that's not a little thing, but it's a short phrase to describe an awful lot of work going into a particular technology. I'll talk a little bit more about that later. There is a new shell script that decodes stack trace, which is used to convert the offsets in the stack trace to file names and line numbers. That was a welcome addition. Those of us who worked in the kernel, working with OOPS reports and stack traces, have been doing a lot of this by hand using GDB ourselves for many years. And then F2FS, which is a popular flash file system, got large volume support. In 3.17, there was really lots of ARM hardware support. Of course, there's always other features going into the kernel that are not related to embedded. So there's things changing with TCP/IP. There's occasionally new syscalls going in. But in terms of new ARM hardware support, there's quite a variety of things. A lot of all-winner code went into the 3.17 release. Rock chip, Tegra board, gumsticks, another TI board. And so this was newly enabled ARM hardware. There was also existing ARM boards that got a lot of improvements. And that should have been a general trend. There's a lot of processors and boards that are maturing in the amount of code they've got mainlined. Also, the K-test module, which is pretty interesting. It had a rework of its config bisect mode. That mode allows you to actually take a configuration. If you have two different configurations, we all kind of know how git bisect works, where you're going through a set of patches and dividing them in half and determining which half the bug is in until you narrow it down to an individual patch. This is the same type of thing except with the configuration. So if you have a configuration where something is broken and a configuration where it's not broken, it'll actually kind of bisect the differences of those until you can figure out, well, which option in the configuration is causing that problem. It doesn't give you the same granularity as an individual patch, but it does help you kind of isolate where the code problem might be. So that's also kind of a neat new thing. In 3.18, we saw overlay FS introduced. I'll talk more about that later. The first of kind of a series of size reduction patches got introduced in this kernel. M-advise and F-advise syscalls can be figured out. There was a lot more support for LLVM, tool chain, compiler, and then some additional SoC support. So HiSilicon shows up here, and some other chips from Atmel and Renesas, Broadcom. In 3.19, we saw the flash F2FS now has a fast boot option. It was a fairly small patch, but it's pretty nice. There's some, I'll describe that more when I get into the technology section. The device tree overlay port, Squash FS supports a more aggressive LZ4 compression option. And then the kind of an interesting thing on there, the Android binder code has been moved from the staging tree. It had been living there for quite some time. There's a long history of the Android code in the kernel, and originally that code was put into staging as kind of a temporary place until stuff got fixed up. And there was some original ideas that maybe this would be integrated with dbus or with other IPC mechanisms in the kernel, but Android is such a big phenomenon, and this is kind of a fragile piece of code. Nobody really wanted to mess with it. And so they just said, well, it is what it is. We'll just take it and put it into the tree as is. So that's kind of a more reflects a shift in the thinking of the kernel developers about supporting Android. And then Linux version 4.0. The first thing that's interesting about this is that this is not version 3.20. Linus conducted a survey on Google+, which is an interesting way. I don't know of any other companies that conduct surveys to, well, maybe, I don't know, maybe other open source projects do for naming and things, but 56% of the respondents preferred 4.0. The name of this kernel is Herder, I'm a Sheep, and that was just a little joke by Linus that he's just following the crowd. But a couple other things. Android Binder received some security hooks. So it had its own security mechanisms, but now you can use SE Linux security with it, as well as any other security module. So it's a little bit more flexibility in controlling the security for Binder. There's some non-volatile memory support patches, which means that you can now put file systems in persistent memory. You can always do kind of a RAM-based file system in persistent memory, but there were some issues with that, and this resolved some of the performance issues there. It's kind of made it more sensible. And so that'll be interesting as we see kind of the rise of non-volatile memory, memristors, and that type of thing. And then also in 4.0, some UBIFS performance improvements. So that's just a really quick overview of the recent kernel versions and some highlights of kind of interesting embedded technology coming out. So a couple of things kind of stick out in my mind to watch. dbus has historically been a user space daemon for handling event notification, device events, plug-in events, things like that. And there's been a movement to work on putting that into the kernel, have a KDBus module. So that's actually pretty interesting. You could view that as a competitor to Android Binder, but it's just kind of, the two are a little bit different. And there's most of the Linux well, I think all of the Linux desktop systems are using dbus, and some embedded systems are using dbus for some of their notifications. In fact, I think Android even uses dbus well, it had anyway, but Android uses Binder for something else. There's kernel tinification. So for many years, we were working on trying to get size reduction patches into the kernel, and then it kind of went stale for a while, but there's been a renewed effort to start submitting patches for that again. And we'll see how small it can get. It actually, people have made some really interesting progress. And if you look at the systems they're targeting, it's because they essentially want to get the kernel down to where it can fit into SRAM, or the whole combination of flash and SRAM. And then people are using systemd in embedded. Systemd is kind of becoming the de facto init system for desktop Linux. And so it's starting to encroach into embedded. Some people like that, some people don't like it. There's still the option, of course, to do your own thing with init. But I think we'll see systemd deployed in embedded systems. And then the last thing to watch, and I'll talk a little bit more about this, is RT3F patches. Again, for a while, there was not much effort to try and put these into mainline. There have been some patches, people have been maintaining the patches on older kernels, but there's not been a whole lot of effort to get stuff upstream, and that may change for reasons that I'll talk about in a little bit. Just a little bit, I want to just look at some kernel contribution notes. I did this, got these statistics by doing just a git log from 3.4 onward, looking at different authors. So this is kind of the domain name of different authors, and looking at the number of commits from these different companies and the number of committers, which is the individual authors. And so you can see Sony Mobile has quite a bit of work to do if we want to kind of get into this. We haven't done so well. LG has been contributing a lot more. Huawei, Qualcomm, and Aurora, and Motorola have been contributing quite a bit. If you look at Samsung, they have really done a lot of work over the last couple of years. And then Intel, of course, has been working in open source for a long time. They have their open source technology center. Of course, so does Samsung now. But it contributed lots and lots of patches. Of course, Intel is also covering not just the embedded space, but also the desktop and the enterprise space. But the thing I find really interesting about this chart is these free electrons guys. They're just like crazy, man. They got 9 guys, and 2 of them have got over 500 patches. They are really doing a good job. These guys are mostly working on. They did quite a bit of the all-winner SoC support, and they did their main customer is Marvell. So they're doing mainlining, and it actually shows me that it is possible to. There are experts out there that if you feel like you want something mainlined, there are people who can help you out. And it's not a huge external cost to do this. Of course, these guys are experts. I don't know how many more people on the planet there are like this, but I think there are people like this, and And so I think that's a really good sign. I think it doesn't necessarily require a team of 500 people to get your SOCs mainlined. And that's, you'll as I go on, you'll figure out why I'm interested in that, because that's a project that I'm working on in the CE work group. So let's now go into individual technology areas. In terms of boot up time, the only thing I kind of saw was this F2FS file system that has a new fast boot option. So it's pretty simple. What it allows you to do is skip some of the boot time checks to reduce the mount time. The way it does this is it just does a little bit more syncing during normal file operation, which means that you do lose a bit of normal performance. So that's a trade-off that you kind of have to choose to do. But if you do that, it does actually significantly improve the boot time for F2FS. F2FS is actually becoming pretty popular. I know it's been shipped in Samsung and Motorola phones, and I believe a few other vendors have also used it for some of their phones. In terms of device tree is the new way to describe the hardware to the kernel. These SoCs, a lot of them do not have discoverable buses. A lot of the hardware just has to be described in a static fashion. But what's happening is all these new drivers are coming into the kernel, and each one of them has to have what's known as a binding. Has to have a description of the attributes that can be described in device tree. Eventually, it'll be a really nice system, but we're in a period of great churn. I think the churn has lasted more than people expected. I think people were expecting the churn to last about 2 to 3 years, and I think it's going to be at least 4 to 5. The DT maintainers are overloaded, so you have these guys who are having to review code for basically all kinds of different areas. And so they're not necessarily subject matter experts in all of the different hardware. They can't be SoC experts on like 20 different SoCs. And so there's just a real backlog. And there was a real good presentation about some of the reasons that this is so by Thomas Penzoni at this year's ELC. So every time I have something in quotes with an author after it, that is a presentation that was given at this year's Embedded Linux conference. And so there's a lot of, you can look these up. I have a link to where the presentations are stored, so you can go kind of read through these and kind of learn for yourself what some of the issues are here. And so people have suggested solutions or possible ways to overcome some of these. Another interesting development in the area of device trees is something called device tree overlays. So it turns out that even with these non-discoverable buses, there are many boards that have kind of configurable on-the-fly hardware. Not necessarily like unpluggable, but things where you might put a cape on the board and reboot it, and it's not something that you can probe to determine what's in that cape. And so it turns out that you actually need device tree changes at boot time. And so there's something called device tree overlays that Pantelis Antoinou has been working on, and there's an article on this on LWVN and a really good presentation about kind of the status of this. So that's kind of a new development in the area of device trees. In terms of graphics, one of the most interesting things I saw at Embedded Linux conference was the Freedreno graphics driver. And this is kind of characteristic. There's been a lot of work on many different graphics chips, GPUs. This is work that was done by Rob Clark of Red Hat on the Adreno GPU that's on Qualcomm chips. And he's got OpenGL ES 3.0 and 3.1 support for the 3XX and 4XX chips. Excuse me. There are still some pieces that need work. It's not 100% complete, but it's amazingly far along. I believe the acid test for this is that you can play Quake, and I believe he's playing Quake on these. And he's also, in the process of this, he's developed some interesting reverse engineering tools. He described some of his reverse engineering methods at the ELC. And by the way, the ELC, right now, the majority of these talks are online in terms of the slides. The video is being post-processed and should be available fairly shortly. Also, there's an article about this presentation on lwn.net. So I think this shows a trend that we are actually making some good progress on open source software support for these GPUs. And I think that's a really good thing. It'll give the open source community a lot more flexibility in the future and the ability for people who own these devices to have more control over the software through all portions of the stack. In terms of file systems, SquashFS supports LD4 compression. That's kind of just another kind of feature for SquashFS. One of the kind of big things that has been added recently to the kernel is OverlayFS, which is support for a read-write file system over the top of a read-only file system. And really the most common use case for this has been live CDs, where you want to mount some kind of read-write thing on top of the file system on the CD. But it's very, very handy for some embedded scenarios. For instance, where you want to have a portion of your file system be read-only for security reasons, or for upgrade reasons, or for some other thing. It allows you to more easily handle that separation between the read-write and the read-only data. And then coming up, we see some proposals for UBIFS handling of MLC NAND. So it turns out that multi-level cell NAND, it has a lot of really complex properties that you have to be aware of all the way up into the file system level if you want to handle it properly. And so there's a lot of people talking about how to put the right characteristics into the file system layer to support that. So a lot of this stuff, when you're dealing with MMC, which of course has NAND underneath, but it's got a file system in a black box sitting in, or at least a block layer in a black box sitting in the chip itself. But if you're dealing directly with the raw NAND, particularly MLC NAND, there's a whole bunch of issues. And if you're interested in that, I highly recommend you look at this presentation. It's actually a little bit frightening as a presentation because the issues are pretty complicated. But it's good to see people are working on it. In terms of just overall file systems, there was a really good talk by Tristan Lalonde. And we get these every couple of years or so. Someone will go off and do kind of an analysis comparing different file systems. And it's good to get a refresh on these because things change over time. The last one of these we did was a couple of years ago, and F2FS did not fare so well. It was a really new file system at that time. But this comparison included ext4, ButterFS, F2FS, XFS, which I wouldn't have thought to include in a embedded file system analysis, and then NILFS, which is a log-based file system by Etiquito Como. Anyway, it turns out F2FS is actually pretty robust, and it's actually faster in many cases. Of course, it's designed specifically for Flash file systems, and these tests were all done on, I think, MMC and ext4 is still a very mature and a robust file system, but I think it's starting to be the case where it's safe to choose some of these other options. And that paper, the presentation gives quite a few stats, all kinds of different workloads and scenarios. And so it's if you're in the process of choosing what file system you want for your embedded system, this is a good talk to look at. This is one of my favorite talks from ELC. I found it very informative. In terms of power management, there's been a couple of different things showing up in terms of trends at recent conferences. At ELC Europe, there was a lot of talk on power management and measurement devices. So there was a lot on measurement and accuracy of measurement and using external hardware for that. At Plumbers, the focus was really on energy management versus power management. So it's not, that may sound like the same thing, but it's not quite the same thing. Obviously, if you use less power, you're using less energy, but there's kind of a balance you make. with the performance versus the battery life. Some of the things that came out of the discussions of plumbers were the desire to have performance hinting from the apps so that that balance could be made better. And then just recently at ELC, I think we saw our first talk on PM domains. There's not the same thing as power domains, but Dirk Utenhoven talked about his work with PM domains, talked about specifically how to integrate that with and describe it all. There's a programmatic interface, but really these days, the way you configure these things is with device tree, and it's complicated, as most things with device tree are. He had a good talk showing, how to set up the PM domains, the right way to structure, and he included the wrong way to structure things so you could see kind of where the problems you might run into were. And then kind of continuing with that, there's been a lot of work in the last year on energy-aware scheduling. A lot more work has to go into that. There's been some division. People have not agreed where some of the information should be kept, if it should be kept down in individual subsystems or put up and made visible to the scheduler. And people don't want to overcomplicate the scheduler, but there are pros and cons to both approaches. Another thing that I thought that was interesting at ELC Europe was idle time prediction. This is when systems, obviously you get a lot of power savings when you can turn the machine off or turn the SOC or portions of the SOC off when you go into idle. And so there are now systems that use heuristics to determine when to plan ahead for idle states. Instead of just reacting immediately to idle states, if you can predict them, know when they're coming, you can do things like schedule set your timers to be together, things like that. Plan your activities ahead of time to save even more power. And then CPU freak. We've had CPU freak for quite a long time, changing the clock frequency according to the demand of the applications and the processes they're running. But there's continuing integration with this into the scheduler, and this is kind of part of that energy-aware scheduling to make sure that you have the right balance between the power and the performance of the machine. And then power domains, which is what Gear talked about, which is sets of devices being treated similarly with regard to power management, how to get things managed properly and together. In terms of real time, the big news here, if you remember my last talk, I was kind of bummed out because the RT preempt patch had seemingly not been abandoned, but it had lost its funding. So there was actually no one paying for any work on RT preempt. Now this patch has gotten a sponsor, and that's good. There are still alternatives to the RT preempt patch. There's ZMI, which uses the Cobalt RT core. That's kind of the dual kernel approach, which has been popular for a long time, and it's very appropriate for some workloads and some software configurations. If you are looking at real-time issues, one of the best talks I think this year on overview of existing RT solutions is this one by Jim Huang that he gave at ELC Europe, RTMux, a thin multiplexer to provide hard real-time applications for Linux. And he actually goes over the pros and cons of both RT preempt, ZMI, and he actually introduces his own multiplexing layer to do real-time. And so it's even if you don't choose Jim's solution, it's got very, very good information. And then, interestingly, there was a talk at DLC, and there are lots of people, especially in the drone community, a lot of people are using programmable real-time units. So they're processors that are to the side of the main processor, and they program them to have very tight loops on them. It's similar to DSPs up to like GPIOs or other things. Sensing things, ordering fixed intervals. As I said, by the drone people at ELC. In terms of system size, so the tinification project, as it's now called, well, it used to be called Linux Tiny, but for some reason the new term is tinification. That project keeps nibbling away at items. There was a patch recently to get rid of users and groups, to only support root, the root user, and this is appropriate, obviously, for only some certain configurations of Linux where you might not care about different security domains on your device. Saves about 25K, and there's a really good article about that. Also, just recently, like a couple of weeks ago, there was a patch to remove kernel command line parsing, and that provides the ability to make any kernel command line option static. So an example is a nitcall debug, and it saves about 385 bytes. That doesn't sound like a lot when you're talking about, a kernel that's 8 or 10 meg, but it's a lot. It's a higher percentage when you're talking about a kernel that's only 1 meg or less. That's just one of the command line options. And it turns out that most kernels have thousands of these, and so the potential savings are pretty big. It depends on how much code you're compiling in. A lot of this savings, interestingly, it doesn't come from the actual static definition of that individual variable, but it's the fact that once the compiler knows that variable is a static or a constant, then the compiler can do constant polling and other optimizations. And so that's where you get most of that savings from, which is really interesting. So it'd be really interesting to see. They only provided an example of one option that they did this on. So it'd be interesting to see what kind of savings when people do it to basically a big group of options. In my test, I did something similar to this a couple of years ago. In my testing, it came out to I think between 6 and 9K, which is again not huge, but you have to nibble away at this stuff. There were some really good talks at this ELC about using Linux on low-end microcontrollers, specifically UC Linux, MMU-less Linux on a Cortex-M4. In particular, Vitaly Wool provided some good data on his system, which he's got running in 840K of text, and that's in an XIP section, and 132K of read-only data, and 86K of data. This was with Bluetooth and no TCP/IP support. Last year at ELC, Vitaly talked about doing that with a 2.6, I think 32 kernel. This year, the big impressive thing was that this is on a recent mainline kernel, much closer to the top of trees. So he was able to actually migrate his system forward. I think this system that he was on had 2 mega flash. No, maybe it was 1 mega flash, and no, it was 2 mega flash and 1 mega RAM, and he was able to run the kernel and in his configuration a small TCP/IP application. But that's actually some pretty small numbers. That's very interesting. Both of those talks, by the way, have very good descriptions of additional areas. Vitaly, in particular, is in progress on several additional reductions for the kernel.
Tim.
Yes.
I actually attended that talk because I was interested in it.
So please change his
I actually attended that talk because I was interested in it. He had it running in 256K of SRAM.
Wow.
He had both his kernel and his user space applications doing XIP. It was very impressive.
Okay. Oh yeah, that's good. Okay. Yeah, unfortunately, I didn't get to see that talk. I always have a ton of things going on, and so I enjoy the video releases as much as everyone else because I get to go back and see some of the information. These numbers were taken from his slides. That's good to know. Thank you. Okay, so moving along, tool chains. So LLVM is being used more and more, including for the Linux kernel. So at ELC Europe, there was a talk by B.N. Webster about the latest update. There were a lot of fixes for LLVM support in the kernel window 3.18 release. And at last count, I've been following this for a couple of years, and they're well under 100. I think they were down to like 46 or so patches. And they've even started building Android with Clang, or C-Lang. I'm not sure how you pronounce that. But Clang is the name of the C compiler in the LLVM suite. In terms of building that, they've actually got Nexus 10 and 7 and 10 booting and can run apps. I'm not sure what the difference is between the 7 and 10 and the 4 and 5. I'm guessing the 7 and 10 are tablets, and the 4 and 5 are phones, and so maybe there's some difference there in the user space stack. But they actually have a bunch. This status is a little bit old. This is probably from the December status. They've got 112 patches submitted upstream to AOSP to fix issues in Android, and 74 of those were accepted, and they have a bunch waiting. So that's actually pretty interesting. So they still find that the GCC performance is slightly better than LLVM. But even if you don't use Clang for your final build, your production builds, actually using Clang during your development is useful because it will find bugs that GCC does not find, and vice versa. So it's a useful secondary compiler to have in your pocket, even if you're not going to use it for your production code, which I think is really good. And they may get to the point where it becomes the preferred compiler. Now let's move on to testing. There's been actually a few different things going on in the testing realm. The first one is a K-self test. So a couple of people, primarily Shuakan from Samsung, have been working on a new kind of a unit or self-test mechanism inside the kernel source tree. And this is the first time we've seen something like this. Although, I don't know, quite frankly, it's kind of a long time in coming. They should have had this many years ago. But you can now just write and from the compiler type make case self-test, and it will compile and run a bunch of tests on the kernel. And it was written by people who are not that experienced and embedded, and so it really kind of operates in a host mode. It expects that the tests you're running are going to be executed on the same machine that you're building on. But they do know that doesn't fly, or that's not going to work for embedded, and so they are working on the ability to install tests. That is actually in the Linux Next branch for the 4.1, so we should see that go in the next merge window. And they're also working on cross-build to be able to cross-compile the unit tests. And then with those two capabilities, the cross-build and the install, we should be able to get these tests built on one machine and then executing on another machine, making it more suitable all, really, for embedded. I just highlight this one. It's one of the smaller tests. It's not that significant, but I added the size test. I think this is a really cool system. So you can actually, you can do this now self-hosted if you really want to check out the size of your running system on like an x86 desktop. That's not that interesting. When we get to the point where we can cross-build and deploy to target, then this size test I think would be kind of cool to have kind of a score going forward for different boards and different configs, and help drive some of the timefication work. Anyway, there's a really good Linux Weekly News article on this, and Shuakan gave a good status presentation at ELC on this. Also, I think in the area of testing, we have a relatively brand new test project, test framework. It's called the Jenkins-based test automation tool. I don't know. We need a new name. That's not a great name, quite frankly. JTA. We need some advertising on it. This was done as part of our LTSI initiative. So it's available now. It is fairly new, so it may have some rough edges. Fujitsu has actually tested the test framework and contributed an ETH tool test. Well, they have some. We haven't really figured out the process of accepting new tests into the suite. There's a Git. It's not GitHub. Bitbucket is the hosting site for it. But we would officially like to encourage people to use the GTA, to send feedback to the LTSI mailing list. There's a eLinux wiki page for this project. So if you just want to drop some comments on that or report feedback, that would be great. We are going to be pushing this really heavily going forward. We want to be talking about it at LinuxCon Japan and ELC Europe, and encourage everyone to try it out. We hope that it will be a benefit to the industry, and that we can rally people around it. It's completely open source. It's based on the Jenkins, which is a continuous build integration system. It's got all kinds of web features and stuff. I don't have time to go into all the details, but we're really excited about it. And I'd like to hope people will find it useful. And then another initiative that was at ELC was kernelci.org. This is a new place that's put together pretty much by some Linaro guys. So Linaro has a test lab where they test their releases. They do continuous integration. I think that's what the CI stands for here. But that is really targeted at Linaro members and Linaro releases. This kernelci.org is focused on doing build and boot testing for anyone's board. It's independent of platform. And it does it on top of tree. So what happens is that once you've got your code into mainline, this will help you find out, just make sure that it doesn't break. And so you can go online. Sony Mobile, when we finally got one of our phones to be booting a mainline kernel, which is harder than it sounds, we actually got a phone over to Kevin Hillman, is kind of the primary driver of this. And we have a phone in that farm, and so we can go online anytime and check and see if there's anything that's been accepted in the mainline that has broken our build or our SoC support. So there's the URL to go look at it. I didn't actually get to this session at ELC, but the site looks very interesting, and you can go to the site and read the FAQ. It's kind of short, but they're accepting boards. So if you want to get a board and you want to get kind of free mainline testing on your board with bug reports, then you should definitely contact them. Let's see. So now, on to CE workgroup projects. So what has the CE workgroup been up to? Well, we have a little bit of contract work. Then I want to go over some of our projects and initiatives, and then later on I'll talk about conferences. So our contract work, we really didn't have a whole lot this last year. We did some stuff with compressed PRITK. We are working on some device tree documentation. The big project that we did was the LTSI test framework, and that was actually generously funded by Renesas. I'll give a little plug to them for that. So for compressed PRITK, this work was done by Wolfram. This project is completed. It was a research project. And he has put the results on the eLinux wiki. He went through a lot of scenarios, did a lot of research into different methods of compressing, identifying the PRITK messages, how to compress them, and he delivered reports at LinuxCon North America and ELC Europe. The unfortunate result of this research is his assessment is it's not worth doing and it's probably not mainlineable, which is a bummer. But he did find some very interesting size optimizations, and he actually, at LinuxCon North America, he was handing out free hardware to anyone who said they were willing to go off and actually implement some of the size optimizations he found and try to mainline them. So I think we'll get some size benefit out of this. He found some really interesting things with there were things like you could just reorder some of the strings and they would end up matching other strings, and so you'd get a compiler deduplication, and it was surprising. Some fairly small things ended up giving like 20K savings, things like that. So he found some good results, but he said the overall it was very, very invasive and probably would not be accepted into mainline, which was too bad. But it was a good project. The other project that we've got still in flight is some device tree documentation. Device tree, I believe, is still a hurdle for people who are new to Linux kernel development. It's been in churn for a bit. People have not really wanted to write permanent documentation because the system is kind of still changing. But Frank Rowan has been collecting data and giving talks. He was at LinuxCon North America and ELC Europe and has collected quite a bit of information doing research on how it works and how to most effectively use it. I'm not sure when this will be released, but it's in progress. And then the LTSI test framework, I kind of already discussed that, so I'll just skip over that. In terms of our big projects and initiatives, well, both big and small, we have kind of 4 things that we're focused on out of this list of 6. Social infrastructure, standard embedded distribution, device mainlining, possibly a size project. That's not one of our major projects, but we're looking at it. The LTSI initiative, which is one of our big initiatives, and then the eLinux Wiki. So if you look at the social infrastructure problem, or the social infrastructure, the goal of this project is to solve problems with Linux for use in social infrastructure systems. Now, social infrastructure covers a big area, and it's kind of like embedded Linux. Embedded Linux can be anything from toasters to hydroelectric dams. So, well, in the hydroelectric dams kind of falls more into social infrastructure. So this is using Linux for like the energy grid or highway systems or things that are big projects with very long-term support needs. And so right now we've essentially been in the requirements gathering phase. There were some BOFs held at ELC Europe and ELC. There have been some Pride meetings with individual companies who are interested in this, and we're still working to define the requirements in the areas, mainly in the areas of functional safety. There's some specific standards that have to be met for software in this space, and then maintenance longevity. There are some real issues with maintaining software over. This is not just 5 years. The minimum most people are quoting here is 10 years, and sometimes 15. And so that is a real challenge for how to set up a system that will support that software for that long that can be shared by the industry so that no one company has to support the cost of that. Anyway, some of the next steps are there will be some additional meetings held this summer to continue to define requirements and hopefully to actually initiate the project to address some of the requirements starting in the fall. Also, an embedded distribution, kind of the same, it's kind of a similar goal is to share the workload of supporting, having an industry-supported distribution. Toshiba has been doing research on a Pokey Debian project, and actually they have a lot of results. They've been researching this for several months, and that will be described in a presentation later today at the Jamboree. So I'm not going to go into a lot of detail, but the next steps for this project will be to write up more detail on the project. I think it's now to the point where people can begin testing and examining what Toshiba has produced, and look if we're going to go solicit funding from the Linux Foundation or start approaching companies about getting them involved and collaborating on this project to see if there's interest in supporting it going forward. Oh, and then a project that I've been working on very closely is device mainlining. And this is to study obstacles to mainlining and work to reduce those obstacles. Some of the activity we've had there is I conducted an online survey in September, had BOFs at several of our recent events. And then I started doing some mobile phone source code analysis, and in particular I had a special interest group meeting. I'll discuss those briefly. So one of the parts of this project is to actually review the source code and see if there are any patterns to the tree that is, to the source that is out of tree. it turns out that mobile phones, mobile devices, tablets, and other things, have between 1.1 and 3.1 million lines of code out of tree. That's a lot of code, and there are some real problems getting that code mainlined. And one of the things I wanted to do by looking at the source and of these different trees was see if I could identify specific problem areas. So I actually have some slides that show some of the source analysis. This was for 9 different phones with 5 different processors. And this is based on 3.4, that's supposed to be an OR, 3.4 or 3.0 kernels. Only one of them was 3.0. Most of these are 3.4. So here's an overview of the amount of code that is out of tree for a shipping phone. So most of these, with the exception of, I think it was Huawei, was on a 3.0 kernel. All of these other ones on a 3.4 kernel, and between Google with their Android changes and the semiconductor vendor and the phone vendor, all of those add a bunch of changes to the kernel. Usually the semiconductor vendor adds the most. But in any event, you end up with at least 1.1 million lines of code out of the kernel, which is a lot. And the same was true, interestingly. Notice the second line from the bottom, the Atom processor, which is an Intel x86-based processor, had 2.1 million lines of code out of tree. So no one is immune from this problem. This is really kind of an SoC problem, a mobile SoC problem, not like an ARM problem. And so that's a lot of code, and it's very daunting to try and get that code upstream. So we've been trying to look and see, well, what are the big areas that are out of tree? So, and I drilled down on several of them that happen to be based on the Qualcomm chipset, and this is actually true of the others, that the mod dash area, the machine area, or the CPU specific stuff was a big chunk of that. Now some of this is because these in 3.4, these trees have not been converted over to device tree yet. But you can see there's a lot of media drivers, video drivers, wireless drivers, sound drivers that should be SoC agnostic. Well, some of them should be. Input drivers, camera drivers, the GPU, and power. These were kind of the top 8 or 9 areas where we're just plain driver code out of tree. And there's really not good reasons. Well, we should be able to get this stuff upstream. And one of the focuses of this effort is to identify, well, what are the problems? Why is this stuff sitting out of tree? Is it just that people have not gotten to it, or are there some barriers? Are some of these frameworks not good enough? And so we're trying to identify those and act on them. So we had a special interest group meeting, and we got attendees from several of the ARM maintainers and companies that are interested in mainlining patches. And we looked at some of the obstacles that we have. And some of the obstacles that were mentioned by people in the meeting were lack of business incentive. That one has been there a long time. But it's kind of more structural. It's not that if these chips were going to stay on the market for a lot longer, there'd be more incentive to kind of support them. But the problem is, in the mobile space particularly, that the SoC is obsoleted within 2 years. And that's quicker than you can actually get the code mainlined. It takes at least 2 years to get an SoC mainlined. The question is, of course, can you get that investment back if you're reusing the IP blocks? You should be able to, but you have to make that business case to the companies to invest in mainlining effort. There's bottlenecks in getting your device tree stuff upstream, and there are, in some areas, there are very unresponsive maintainers. Arguably the most successful SoC maintainers or SoC upstreamers is the Free Electrons guys, and they said there were just a couple of maintainers that really, really slowed them down. And so we talked about ideas how we could help those maintainers. Maybe they're overloaded, either assisting maintainers with paid help, trying to educate companies on the benefits of getting code upstream. We could actually show that their code, even as they migrate through their SoC family, that as they're reusing IP blocks, they'll get a benefit from having that code upstream. The other thing was creating, an idea that was mentioned was creating an SOC staging area, particularly for unstable device tree bindings. And first we have to convince the community that unstable device tree bindings are something that should be in mainline. Right now they're not convinced. So some of the next steps for this is we need to process that input from the special interest group meeting and kind of push it back to different organizations. So some of the most promising ideas was to have the Linux Foundation, possibly working with Linaro, fund key kernel areas. We need to figure out what those are. Some that come to mind are USB kind of sticks out, wireless sticks out as something that might be common between different kernel vendors. Also, we might want to fund a developer to be a co-maintainer in certain areas where we kind of seen a weakness in the current maintainer. We need a method to kind of find overloaded maintainers without being in kind of a positive way. We want to help people. It's not our goal to kind of shame them or call them bad names or anything, but we just want to make sure that we help overcome any obstacles. Another thing that I'm working on is actually a white paper on overcoming some of these obstacles. And that's based on a talk that I've been giving on this topic. Let's see. Then the next project, as I said, this is just a possible project. We're currently looking at it, is a possible size project for the CE work group. So there are separate people, companies, working on kernel size reduction packages. Vitaly Wool, Jim Huang, a bunch of people at Intel. Josh Triplett now manages Linux Tiny Tree. And so we're actually looking right now to see how the CE work group could contribute to that effort. I don't think we'd start our own, but we just kind of go in and kind of in an organized fashion try to help out. And then the long-term support initiative. Again, this one, you'll have a presentation later in this event, the Jamboree, to get an update on this. So I won't go into a lot of detail. There are a lot of presentations on the status of this. And the test firmware, I think, is one of the biggest pieces of news about this. And then a site to maintain and support is the eLinux Wiki. Whenever we have contract work or results, projects, we try to document it out on the wiki. There is, because it's a wiki, there is kind of a lot of old information, but there's also even old information in a lot of cases is still useful, particularly in boot up time, real time, security, power management. You can find all kinds of information out there, debugging, how to debug the kernel. We are working on a few new wiki projects. There's a video transcription project. We're trying to go back and identify some of the kind of the best talks that we've had at ELC and see if we can get them transcribed so that that they're like web searchable and you can read them instead of having to listen to them and take an hour to listen to them. Finally, I want to get into some other stuff. Just kind of quickly, hopefully, just talk about a couple of new projects in consortia. Go over distros and build systems, and then talk about events. So projects in consortia, the All Scene Alliance is peer-to-peer ad hoc networking. When I wrote these slides, I should have thrown in IoTivity, or the OIC, which is another IoT stack. And then at our event, we had Panasonic announced OpenDock, which is another IoT stack. So we have an abundance of Internet of Things stacks for Linux. The Purple Foundation is a multi-company MIPS nonprofit. So they're doing some projects around MIPS, supporting MIPS QEMU. It's good to see someone besides ARM focusing on SoC support in Linux in kind of a collaborative way. And then Drone Code is very exciting, open source UAV software. We had our first Linux Drone Summit at Embedded Linux Conference. Andrew Tridgell was actually on the ELC program committee. And so we were able to get quite a lot of really good content, and it made for a fun demo session too, to see all these flying vehicles and cool demos. We're a real nice vertical industry. In terms of distros, Android, arguably you can decide whether you want to call it an embedded distro, but its Lollipop is now shipping. Phone vendors are now rolling it out. It's in AOS. I've been out in AOSP for some time. There are lots of changes in the upper portions of the stack. Some kernel level changes, not a whole lot happened in Lollipop. One that was interesting to me, because I used to work on this, was Android no longer uses the logger kernel driver. They've now moved that into a user space kind of syslog style driver. Big news, I'm very excited about this. I know Rob is as well. Is Toybox is now included in AOSP and should be in the default builds for the M release. So that's very exciting. I am so excited to use Find on Android without going to a bunch of extra steps. And all the other benefits that kind of a nice POSIX toolkit will provide for Android developers. So kudos to Rob for all his work on that. In terms of Tizen has been doing, they've been focusing quite a bit on the automotive space, and they've been doing a lot of security work with SMAC. And they also have come up with a new, interestingly, user space-based access control broker for some of their stuff called Sonara, which is a kind of a different architecture, but they simplified the rule sets quite a bit. They have talked quite a bit about that. You can read the LWN.net article. But the interesting thing here is it's not Tizen specific. So if you want to use SMAC, and I think Sonara as well, and you're using the Octo project, they have made all these recipes available and put them in a meta layer. So you can actually just go out and reuse their stuff. Of course, you kind of have to learn their security model, what their labels are and stuff, but it's interesting to see that type of sharing happening through the Octo project. And then a distro I'll let Kobayashi-san talk about later is the PokeDebian distro. And so I'm not going to talk about it here. I'll let Kobayashi-san talk about that after lunch. The Octo project is kind of chugging along. This is kind of a big industrial open source build system. Recently been promoting their what they call Toaster, which is their web interface. The features in 1.8, most of these are related to Toaster. Being able to import and build your own custom layers. From inside the web interface, setting configuration variables or adding packages, selecting the targets and building them and other stuff. Download artifacts, that means pushing stuff to the client from inside the web interface. That used to be possible. There's a lot of kind of manual BI style things you have to do to get that to work. There's been lots of projects that are making meta layers for the Octo project. So things like I just mentioned, the Tizen security layers. I think the UAV stuff is showing up as a layer, and other things are showing up as layers. So it really is kind of starting to become an industry standard. But it is a kind of a heavyweight industrial grade interface. It takes quite a bit of, there's a big learning curve to learn the Octo project. And you need kind of a team of people to work on it if you're going to kind of maintain a distribution long term. So you need to get slides. Unfortunately, the slides for the Octo project sessions at ELC have not shown up yet, so I need to bug those guys and get their slides. The other build system that is very popular and is continuing kind of as the simpler alternative to Yocto project and Open Embedded is Buildroot. This has over 600 packages. They continue to add features. So they now allow def configs and recipes from an external tree. You can check the integrity of downloaded archives. They can report licensing information. And all of these features are something that's kind of in the Octo project. But so Buildroot is in a way kind of catching up. What they tend to do is they tend to do it in a kind of a minimalist or a very simpler way. Yocto project kind of tends to do things, cover all the bases, and Buildroot is trying to kind of get features, but not at the same level of complexity. Anyway, there was a good talk on kind of the status of Buildroot by Stephanie Lockwood-Child, ELC, so that's a good one to look at if you want to play around with Buildroot. In terms of events, we just had Embedded Linux Conference 2015. The presentations are online. So ELC is kind of divided into two parts. There's the Android part, and then we had a bunch of tracks on embedded and other topics. So we have I would guess about 70% of the embedded presentations are online. We still need to follow up with some of the speakers. They're supposed to submit the slides ahead of time, but often they sneak by without doing it. So we're going to continue asking them to send presentations to follow up on that. Coming up in about a month and a half is LinuxCon Japan, and I'm happy to say I will be there. So if any of you are at that event, I'll be happy to meet you. And then Embedded Linux Conference Europe is coming up in Ireland this year in October. And then next year, Embedded Linux is going out of the Bay Area for the first time ever. Not very far, though, well, I don't know, I guess far as the crow flies. San Diego, but we're staying in the state of California. We'll see if we want to move it around to other places in the U.S. So my overall impressions about Embedded Linux Conference, it was our biggest ELC event yet. We had over 600 attendees. The theme this year was drones, things, and automobiles. Drones is very exciting. It's an exciting area. It represents kind of just one vertical market of embedded Linux. Something I've kind of noticed is they really need RT preempt. So it's very good that someone picked this up as a sponsor. Otherwise, if you look at what they're doing, they're using standard Linux features. They ported their software, really, one of the main UAV stacks is just ported from their Arduino, and so Linux has all these features they're not even using. So they don't have a lot of requirements other than RT that are outside of the kernel. They have lots of interesting technology and features in their space. A lot of really interesting stuff going on, all up in the stack outside of the kernel. But it's all Linux based, which is really neat. And I think Linux is really poised to take over as kind of the chief operating system in this market. Automotive seems to be going along fine. I kind of worry whether we're getting sufficient traction. I'm not in the automotive space. I'll be attending an automotive Linux event in a couple of weeks, so maybe I'll get a better feel for that. So hopefully things are going well. I kind of worry whether or not we're fending off our competitors there. We'll have to see what goes on. The other kind of big focus was the Internet of Things at ELC. I think it's kind of a done deal. I think Linux has already kind of won, if you want to use that term, the cloud and the gateway. And it was interesting, I did a panel at ELC, and the people there didn't even kind of consider Linux in the sensor space. They just thought it was just too big, or it didn't even, for some of them it was like the thought was foreign to them that you would be running Linux in a sensor. So maybe they're thinking about 10K sensors or something. But I think it's still possible for Linux to, I think there will be sensors where it doesn't make sense for Linux to run, but I think that there's a lot of territory we can get to if we can get the size reductions down. I think we could, my goal has been for a couple of years to get Linux running on a 10-cent processor. And so we'll see if we can do that. Other areas that kind of need to be improved besides size in order for Linux to do well in the Internet of Things is we need a lot of security improvements. That's one of the biggest problem areas with the Internet of Things. And then infield upgrades, which is not really a Linux problem. That's kind of outside Linux. But there are some Linux features that can help with this. Other problems with the Internet of Things are not really having to do with the technology so much, kind of the OS technology, but more things like the infrastructure, handling huge amounts of data transfer, and the security and privacy of that, and social issues like whether people are willing to allow their data to be used in certain ways. Those problems are kind of outside the space of what a technology consortium worries about. We have plenty of IoT stacks these days, including the new one from Panasonic that's been released. So I don't think there's no shortage of options for people who want to do Internet of Things with Linux. My final thoughts overall is there's a lot of things we can still improve in the Linux kernel, in the Linux user space stacks, especially with regard to mainlining. We have a lot of work to do to get our SoCs supported properly. But overall, I think embedded Linux is doing very well. And so I'm very happy with the way the industry is going, and I appreciate being a part of it, and I appreciate your taking some time this morning to listen to my status presentation. So thank you very much. The last thing I have is just where I get some of my resources from. I get a lot of material from lwm.net. And I also, when I go through my kernel versions to see what's new, I look at kernel newbies. I'm going to have to change that 3 there to a 4. And then the eLinux wiki has the slides for the different events, and I review a lot. There's tons of great material that happens at every event. We try to preserve it, so even if you could not attend the event, you can go see what's going on. And then the eLinux dev mailing list. Anyway, thank you very much for your time. And I don't know if there's time for any questions, but
yes, of course, yeah, good time to make questions and discussions. I hope you to use this microphone because of the your voice is picked by this microphone through the speaker, so that if you do not use the microphone, maybe it's quite hard for him to listen to you. And also, here is a magical this microphone that is ultra red, telecommunication here, so that if you hide this portion, the microphone will never collapse, so that please do not hide here. So, any question or discussion to him? Unfortunately, this time you have to speak English, but it might be a good time to train your English. Maybe it must be better than making some of the examination of the some quite naughty and annoying that there's a TOEFL or something like that. Anyway, you have.
Tim, you were talking about trying to get Linux running on a 10-cent processor. I've been using the phrase disposable computing for the next step of embedded for some years. You might find that somewhat useful. I also wanted to ask a question about one of your slides that you went past fairly quickly was talking about a standard embedded Linux distribution.
Yeah, let me go back and see if I can. Well, so this says embedded distribution. I think I had the standard written on, where slide was it?
I think you mentioned the word standard.
I did say standard on one of my projects and initiatives. Here it is. The second bullet, standard embedded distribution. We're trying to figure out whether we want to continue to call that standard, so we don't want to scare people off. So we're just saying, I don't know if we'll call it like a shared embedded distribution, but we'd like to, we're not trying to set a standard, we're just trying to create a single place where people can collaborate on the maintenance of a distribution. So,
okay. I just wanted to draw your attention to XKCD 927.
Yes, I know.
Anytime that someone is planning something that is summarized by an XKCD, that's its own category of thing. So.
Well, yes, and that's exactly why we should avoid it. Well, I'm gonna let Kobayashi-san handle that in his presentation about the distribution. So no, actually, the one we're kind of leaning towards is this PokeDebian, which is not creating a new standard. Well, I don't think it is. What we'd like to do is we'd like to leverage
You'd like to increase the gravity of an existing project.
Yeah, and just so we're not having to do the same types of like, we don't want to, well, I can tell you what happened at Sony, right? We have our own distribution internally, and we would go cherry pick all the security patches from Debian. And so like if we could have, if we could share that workload with other groups in the industry, that would be beneficial. It's kind of silly for a bunch of people having to kind of go through the security list and look for patches, and we're all using a lot of the same base source packages, right? So that's kind of the idea there. Yeah, we don't want to. I'm very familiar with the XKCD that you mentioned. It's one of my favorites, actually. I don't. For other people, it's talked about when you have. If you have 14 standards and you decide you're going to do a standard that encompasses them all, now you have 15 standards.
Thanks, Scott. Any other questions or discussions or suggestions or talks? Whatever. Anyway, it seems to be everybody is satisfied. So that thank you very much, team, and have a good evening today.
Okay. Well, thank you for letting me participate, and I hope you have a good rest of the conference.
And see you at the LinuxCon Japan in Tokyo.
Yep, I look forward to being over there in just about 6 weeks. So,
Thank you very much.
okay, thank you.
So.